Okay, so moving to the next page, we're in video 3 of the first section. We're going to take a look at the algebraic functions, and that's really why I've had this graphing calculator going on the screen, because a lot of this class, you're going to be able to evaluate your functions, of course, algebraically, working with factoring and solving for x values and y values, setting things equal to 0. That's certainly a part of college algebra. But you're also going to be graphing them and taking a look at them visually and using some of the functions on the calculator to make your life a little bit easier. So, starting off, we're a function, or it's a function, I should say, when you have an input and an output that will produce a single formula, y equals f of x. And then, that's the relation definition. And then the x values, the input values, do not repeat. So x values, go ahead and finish it, do not repeat. All right, so once again, so just the definition. The domain is to set up all the values of x for which the formula gives you a meaningful value to the corresponding y values. Once again, you can have some x values that do not produce anything in the function. They're not part of the function. And if you have those x values that are not part of the function, then they are not part of the domain. Now, I just need to take a moment and show you this, just remind you what that means. This is a notation for numbers along a number line. So on our number line, we have negative infinity to the left and positive infinity to the right, and then all the real numbers in between. So let me just throw some numbers on there. -4, 0, 2, 1, 5. There we go. Not drawing a scale, just go with it. I just want to remind you, on a number line, if something is not included, we put an open circle, and then if something is included, we put a closed circle. And I'm going to draw something else right here. 0 to that. Okay, so let's say this represents something I solved, and I want to figure out what this little thing right here is in terms of the x values. So if I was going to write it with this notation, I would say that the x values take the values between -4, not included, to 0, included. And then it skips this little region in here, and it picks back up at 5, not included, and goes on to infinity. So I would write this as -4 to 0. And then with this bracket notation, to show something's included, we put something called a hard bracket right there. And then we do this little funny thing with a U that stands for union. It's going to take this region of the number line and it's going to put it with the other region of the number line. So union, and then 5, I put a parentheses, or in this notation, sometimes it's called a soft bracket, parentheses, to show that the 5 is not included. And we go off to infinity. And then we know we're going to infinity because of that arrow. And if you remember, infinity is never contained, because it just keeps going. We're never going to have a set number for infinity. So infinity always gets the parentheses, or the soft bracket. And this thing right here that I just wrote with the parentheses and the brackets, that represents what this drawing is trying to tell us. So let's take a look at the equations given to us in example 7. First off, we take a look at this, and if you're going to put it on your calculator in function view, notice over here it says y equal. So we're going to need to get y by itself in all of these if we want to have any hope of our calculator graphing it in function view. So I have y equals 4 plus x. If you want to write y equals x plus 4, go for it. I know some of us have been taught to always put the variables first. But just to remind you, it might have been a while since you picked up your calculator. Y equals, you have all these different y values. Your variable button is right here. I'm going to have 4 plus x. And I'm going to hit graph, and there it is. Now, when you're inspecting the graph to see what the domain and range might be, if you remember, you look for any breaks in places that the graph stops. And when you have those things, those places are not part of the domain. But I'm going to go ahead and say this is a line. And if you remember, a line is infinite. So the domain of this line is from negative infinity to positive infinity. Done. Life is good. Okay, so on B, I'm going to solve it algebraically just because I like to do that. And it's been a while since some of you have done this. You might be a little bit of a reminder of what to do with an equation like this. And then we're going to take a look at the graph. So let's clear this guy out. If I want to get this on my graphing calculator, I'm going to have to get y by itself. So the first thing I'm going to do is I'm going to take everything with the y and put it together. And I know some of you may have been taught specific steps of how to do this. Y goes on this side and all this other stuff. And it's perfectly okay if that's how you want to do it. But I don't tend to get caught up in that. I just try to do whatever I can as fast as possible to get the y by itself. I'm going to move this constant over. And I have 3x squared minus 2x minus 5 equals a negative 5y. Right. And the last step is to divide by negative 5. And when we do, remember it changes the sign because we're dividing by a negative. So I have a negative 3/5 x squared plus 2/5 x plus 1 equals 5. And once again, I just divided everything by a negative 5. All I did, all the way across. And then I wrote it as a fraction just to have it easier for me to look at. Now, I'm going to enter this into my calculator. And it depends on what type of operating system you have. But hopefully you have the most upgraded system. And if you have the most upgraded system, you know there's something called map print, where things look like what you have on your paper. And to get to the fraction, you hit alpha y equals, and you have these options come up. And I want to put a fraction in, so I'm going to hit number 1. And then I'm going to have a negative 3. And then down here, I'm going to have a 5. And then I'm going to have an x. And I'm going to square it. So there's the first term. And I'm going to have plus, and I'm going to grab my fraction. I'm going to say I'll have 2/5 x plus 1. And I'm going to hit graph. And we have a beautiful parabola. Now, if you remember in previous math classes, we probably talked about this function quite a bit. We're going to talk about it as well. We're going to get some discussion about it. But notice it's a nice line. It's assumed to go on forever. So when we take a look at this guy, we're going to say that this nice polynomial function has an infinite domain. If you wanted to make sure, you could always zoom out. I hit the zoom button, then number 3, hit enter, and it gives you a really zoomed out view. And you can see it's still that graph. Now, every time you do a zoom in or out, always go back to a zoom 6, get it back to the standard view, so that the next time you graph, it doesn't look really weird to you. So this guy has an infinite domain as well. Negative infinity to infinity. Wow, I drew those infinities beautiful, didn't I? All right, now this one, it depends on your level of math experience at this point, if you recognize that this is a function or not. I'm going to go ahead and say it's not a function. We're going to talk about why. So this one's a function, this one's a function, C is not a function. It's not a function because the y has a square on it. Now, you're going to see that when we start working this thing, this problem, when we try to get the y by itself, and I'm going to start off by subtracting x, you're going to get to a point where you have a y squared completely by itself. So I'm just doing the math as before. I subtracted x from both sides, and 3x minus x is 2x. And then I had 2y squared, so I'm dividing everything by 2. I get y squared equals x plus 2. And you notice over here on your calculator, there's not a y squared. So you have to put this y by itself. And to do that, what we're going to use, and this is just an example I'm pulling out of my head. It has nothing to do with this problem. Okay, just going to remind you that if you have y squared equal 9 and you want to get y by itself, you're asking yourself, what value did I square to get a 9? And if you think about it, you can square a -3, because -3 times -3 is a positive 9, and you can square a positive 3. So we say that y squared equals 9. Then to get y by itself, we're going to undo it, the square, by taking a square root. And the square root and the square, you can't see me, but I'm throwing up air quotes right here. They cancel each other, and that's where the air quote came. It's not really canceling, but we're not going to get deep into it. And we end up with y equals, and the thing is, it's not just the square root of 9. We have plus or minus the square root of 9. Because, once again, the square root of 9 is 3. I could take -3, square it, and get a 9. Or I could take +3, square it, get a 9. So I have two answers for y. Remember that I hope you remember that from previous math classes. So what we're going to do, let me erase this so I have room to write, is for the function that we're looking at, we have y squared equals x plus 2. So we're going to take the square root of both sides, and we're going to have plus or minus the square root of x plus 2. So we actually have two functions of y. Now let me pause for a moment before I graph it. And let me just remind you, you can solve this algebraically all day long. Because this is a square root, and you remember that with square roots, you cannot, that's a not, have negative values. You cannot, unless you're going to talk about something called imaginary numbers, you cannot figure out the square root of a -3 in a real number system. This is, nope, not going to happen. So if you wanted to find the domain, or in other words, all of the x values you can plug in underneath the square root, then what you're going to say is, I need to take this equation and I need to find everything that will keep this x plus 2 positive, or non-negative actually. So we're going to have x plus 2 is greater than or equal to 0. Because anything bigger than 0 is positive. I know, you got that. And then this right here, that the equal to is okay as well, because the square root of 0 is just 0. So we're good. So if we wanted to get the domain of this, we would simply say, whatever is underneath the square root has to be bigger than or equal to 0. And that means that x has to be bigger than or equal to -2. So if we wanted to put that into that notation of above, since it's equal to, the -2 would be a solid dot. And since it's bigger than -2, we'd be going to the right. You would say the domain is from -2 to infinity. Okay? That's great. That's wonderful. But that right there, if we take a look at the graph, we're going to see that, let me get it in. Here's my square root. X plus 2. I'll do my graph. That's exactly what we thought it would be. But notice, I know some of you are already thinking it, but she only did the positive one. How do you do the negative one? Because we actually have two y's here. So what we really have is y1 equals the positive square root of x plus 2. And y2 equals the negative square root of x plus 2. So I'm going to go back into my y equals. I'm going to go down to y2. And I'm going to do the negative. See, the negative's on the outside. Square root of x plus 2. And when I graph this one, we still have our domain. It's from -2 to infinity. So once again, domain has to do with the x. So this is our x. -2, moving from left to right. It starts at -2 and it just keeps on going. So that is our domain. All right, so algebraically on part D, we'll just circle that. Let's circle that and that. There's our answers. On D, square root, this has to be non-negative, so it's got to be greater than or equal to 0. It's just one square root. There's not a plus or minus in front, so I'm just dealing with one of these graphs. And so I have 3x has to be larger than or equal to -2, and x has to be larger than or equal to -2/3. And if we wanted to see that visually on our graph here, figure out what we're doing, I'm going to have the square root. I'm going to graph this guy right here in y1 of 3x plus 2 and graph. There he is. Now you notice it's hard to tell right there where the domain starts. So we're going to talk about that too on the calculator in the next video. But solving this one was so simple. We have x has to be bigger than or equal to -2/3. Then what we would say is the domain is from, oh, and I messed up here, didn't I? I'll come back in a minute. The domain is from -2/3, and it's included, and then it keeps going to the right, infinity. So there's our domain. Now, I caught an error just then. My domain here, there was an equal to, and I put a soft bracket or a parentheses there. This domain should actually be on these, and I apologize for that. I'm glad I caught it. So this should be a hard bracket because the -2 is included. All right, so we're going to talk a little bit more about how to find that -2/3 on our calculator in our next video, and we will still be working through section 1.1.